Built to withstand treacherous storms, this 11,000-ton Titan operates 24/7. The world's thirst for oil pushes this mega rig to drill deeper and its workers to drive harder, risking their lives. Shipyards must build new rigs faster to meet the exploding demand for these ultimate oil rigs. The modern world runs on energy. Every day we consume more than 80 million barrels of oil and more than 250 billion cubic feet of natural gas. But oil and gas are getting harder to find, and new reserve discoveries are getting smaller. It's a squeeze play that's forcing energy companies to search in some of the most treacherous places on the planet. Like the North Sea, a tumultuous body of water between the UK and Scandinavia. For thousands of years, sailors have feared the North Sea for its storms. Its waves can crest to 85 feet, making drilling for oil or natural gas here nearly impossible. But buried beneath the North Sea are 15 billion barrels of oil and 170 trillion cubic feet of natural gas, so it's worth the risk to pursue it. To get to those reserves, it takes more than just an oil rig. It takes a mega oil rig like the Noble Piet. This 11,000-ton monster can drill wells nearly 5 miles beneath the sea floor. Its heavily reinforced hull and legs are designed for harsh environments like this. The Noble Piet is well armored to withstand this killer corner of the Atlantic. Since 1980, more than 350 North Sea oil and gas workers have lost their lives.
Explosion and fire on the Piper platform.
Drilling in these notorious waters is dangerous business. The Noble Piet is about to embark on a new mission, drilling to tap a reservoir of natural gas worth almost $350 million. This oil rig is perfectly adapted for its mission, to travel the oceans of the world and drill for precious oil and gas deposits buried miles below the sea floor. But it's not like a ship. It has a 342-foot retractable leg at each corner. Tugs tow the rig to where petroleum is likely to be found. Then powerful motors drive these legs down through the water and deep into the sea floor, anchoring the rig in position. Standing on 3 legs like a tripod, the rig is so stable it can even drill during a North Sea storm. And that's crucial, because on the Noble Piet, it's all about the drill. Housed in a 147-foot tower known as a derrick, the drill digs a shaft to pockets of oil and gas trapped in layers of rock. Everything else on the rig is there to support the drilling. Up to 80 people run the operation, so there are 4 floors of living quarters. Below that, equipment is stored in a 25-foot tall steel hull, including 6 1,200 horsepower diesel engines that keep the drill running and the lights on 24/7. The operation costs over $55,000 a day, so anytime the drill stops, they're hemorrhaging cash. So the rig and its workers are pushed to the limit. Workers put in grueling 12-hour shifts for 2 weeks straight. Then they're airlifted off the rig for 2 weeks of R&R. Every job here holds hidden dangers. Crushed hands, broken bones, and even death. The risks are high, but so is the money. Salaries are up to $100,000 for 6 months' work. And that draws workers from all over. Lithuania, Malta, Portugal, Norway, France, 9 countries in all. They earn every penny because this megastructure never stops working. But even if they strike the mother load, it won't be enough. In fact, all the oil rigs drilling in the oceans around the world, and there are more than 500 of them, can't keep up with global demand. So companies are racing to build more rigs as fast as possible. That building them calls for specialized mega manufacturing sites, giant shipyards that can mass produce these maritime monsters. One such shipyard is in Southeast Asia, near the western end of Singapore. called the Keppel Fells Pioneer Shipyard. It's building more mega oil rigs than any place else in the world. Some shipyards have just a few hundred workers, but here, 4,000 people report for work each day.
Hey, one man stand behind,
It's as big as 52 football fields and stretches over 69 acres. Its only product, massive oil rigs. This gargantuan dry dock could swallow up 24 Olympic-sized swimming pools. Right now, this Singapore-based company, Keppel Fells, is building almost half of all the world's new oil rigs. To hang on to their market share, they've got a bold strategy.
During the good times, we try to build as many rigs as we can.
They know that when fuel prices skyrocket, they can sell as many of these babies as they can make. But they've got to build them fast before the market cools down. A typical shipyard builds 1 or 2 rigs at a time. But this mega shipyard is designing, engineering, and building an incredible 23 oil rigs at once. They cost between $130 and $450 million each, and the customers all want them yesterday. With literally billions of dollars at stake, time is money, and there's no room for error. One mistake could cripple the company and delight their competitors. Shipyards from Mississippi to South Korea would love to snatch away Keppel Fells' business. They're the leader of the pack, so they have the most to lose. But this Singaporean company has an edge. More than 35 years of experience building rigs in tropical heat and humidity. And the heat is on when the shipwrights get down to work. When you're building 23 rigs at full bore, any slip-up could shatter the production schedule. So the company has spent decades slashing inefficiencies in their production methods.
We try to innovate our processes in construction and so on, so that we can build better, safer, and cheaper.
And faster. To speed up the process, they first build the entire rig in space. Cyberspace, that is.
As you can see here,
The engineering team works with the latest marine architecture program. This is the design for a new state-of-the-art oil rig. 225 feet long, with 517-foot legs, and up to 5 decks of living quarters to house 112 men. It's one of an advanced, super-efficient new generation of rig. It will drill deeper and faster than older rigs, turning this design into an actual rig. Is like putting together a jigsaw puzzle, except this puzzle is enormous. It's made from 25,000 pieces of steel, and 100 lives will depend on how well they fit together. Even with methods this efficient, and 800 workers devoted to this one rig, it still takes 6 months to go from cutting individual steel plates to finishing huge sections of the rig. This section is part of the hull, where giant pumps will be housed. It's as big as a locomotive, 66 feet long, and more than 60 tons. When huge sections of the rig are finished, they're moved to the dry dock, where they are stacked and welded together piece by piece until the rig starts to take shape. So far, construction is on schedule, but the tricky part comes next, navigating the rig out of the dry dock and into open water. This megastructure is still half a year from completion, when it will join the worldwide fleet that's feverishly drilling for oil and gas. Back in the North Sea, a French gas company has hired the Noble Piet to drill a new well. The rig must literally mount on and drill through what's called a permanent platform. The permanent platform is the structure shown here, just to the right of the Noble Piet. These platforms are placed where scientists, using advanced instruments that can see deep into the earth, determine that large reserves of oil and gas are likely to be found. This platform already has a number of working wells connected to pipelines sending the fuel to shore. But now it needs a new well, and it can't drill one on its own. That's where the Noble Piet comes in. Many rigs can't handle this job, but the Noble Piet fits the bill because it can actually raise itself more than 7 stories above the sea. Huge electric motors turn massive gears that hoist the entire hull out of the water, jacking it up into the sky. Called Jackup rigs, they can position themselves over permanent platforms for drilling. It sounds easy, like jacking up a car, but lifting this massive rig is the equivalent of jacking up 7,000 cars while balancing on stilts in the middle of the ocean. So Dutch barge engineer Paul Kroner has reason to be nervous. He's about to jack up the Noble Piet.
Stand by for jacking.
36 electric motors, 12 on each leg, slowly turn the giant steel gears. To avoid a jam, rig workers slather grease where the gears will engage. One stuck gear could halt this mission before it even starts. Gradually, the rig begins to lift. "60 minutes later, the rig reaches its high point, 86 feet above the water. But it's still not ready to drill. The Piet's drilling derrick needs to slide out over the top of the permanent platform on a huge movable arm. Then the drill can drive through a hole in the platform and down into the seabed. It's up to Dutch drilling expert Dennis Sellen to execute this move. He activates 4 massive pistons that slowly begin pushing the 926-ton arm out over the permanent platform. Each piston is powerful enough to move 6 bulldozers. The team closely monitors their coordination.
Yeah, it's going all right?
Starboard side ready.
All 4 pistons must push together to ensure the arm moves straight ahead. If one piston goes faster than the others, the arm would jump its track, bringing the operation to a dead stop. It takes more than an hour, but at last, the arm is in position, and this megastructure is ready to drill a new well. But this job requires patience. Grinding through miles of rock to find a reservoir of natural gas will take at least 8 weeks, if they can find it at all. And the crew of the Noble Piet will have to stay on high alert the entire time, because accidents and death threaten every rig worker in the North Sea. Workers walk a fine line between safety and speed, getting this mega oil rig up and running. Every day this North Sea mega oil rig isn't drilling wastes $55,000. But even though it's in position to drill, drilling hasn't begun yet. That's because the Noble Piet's roughnecks, the workers who actually man the drill, must still haul more than 500 lengths of pipe from the main deck up to the derrick. They will shove this drilling pipe into the earth one piece at a time for miles. Each section is 30 feet long and weighs almost half a ton, so this is a huge job. It takes a winch and plenty of roughneck muscle to haul these pipes up into the derrick and onto the drill floor where the drilling takes place. The drill floor is one of the most dangerous places aboard a rig, and it's drilling chief Tony Wiltshire's job to make sure that everyone stays alert and safe.
Make sure that this valve is okay, because it's a safety valve, we might need it in case of emergency.
Here, a careless worker could find himself on the wrong end of a swinging pipe. Though Tony's concerned about safety, he's also worried about speed.
In drilling, you always talk about economics. How faster it goes, how better it is.
To work more efficiently, the roughnecks join 3 pipe segments together ahead of time and stack them in the corner of the drill floor. Once they've stacked them all, they're finally ready to drill. Now it's time for this rig to start making money, they hope. There's no guarantee that this well will strike any oil or gas. In fact, in remote areas, half of all drilled wells strike nothing at all. To improve his odds, Tony's assembled a very experienced crew of roughnecks, led by Maltese driller Noel Chembry. But Tony's team has their work cut out for them. The client, Gaz de France, thinks it's located a new reservoir of natural gas almost 3 miles beneath the sea floor. But to get to it, the crew will have to drill at an angle through 40 layers of rock. By adding or removing weight from the drill pipe, Noel can control the direction of the drill bit. Under such immense weight, even steel pipe becomes flexible. But Noel needs to be careful because the rock is riddled with high-pressure pockets of seawater. If the drill nicks one, the high-pressure water could flood back up the hole with such force that it could destroy the well or even damage the rig itself. So Noel will have to thread the drill between these pockets like a needle. A needle that's miles away that he can't see. He has to trust his instruments and his equipment, a $30,000 diamond-tipped drill bit, and a 1,000 horsepower engine capable of rotating almost 750 tons of pipe. Noel sends the drill bit down the hole to the ocean floor. Soon it will start to chip away at the rock below, excavating a shaft towards the gas reservoir. Once one length of pipe has been pushed down the hole, the roughnecks connect another. This process continues until, hopefully, they hit their target. It will take at least 8 weeks, if everything goes right. And the driller needs to keep a vigilant watch over his gauges the entire time. A pressure drop or a change in drill speed could indicate impending disaster, a cave-in. During a cave-in, the walls of the hole collapse, destroying the well and trapping the drill bit thousands of feet below the surface. But drillers have an unlikely secret weapon to defend against cave-ins: mud. On the drill floor, mud is everywhere. But this mud has no dirt in it, and it doesn't come from the earth. It's actually a sophisticated blend of chemicals pumped into the well to lubricate and cool the drill bit. The mud also performs another function. Its weight pushes out against the walls of the hole, helping to prevent cave-ins. Every type of rock that the drill passes through may need a different mixture of mud. Use the wrong blend and you could ruin a drill bit or destroy the well itself. So mud engineer Michael Schofield can't afford mistakes. In his lab deep within the bowels of the rig's hull, Matthew tests and retests his mud mixture until he finds the perfect recipe. Then roughnecks churn out 150,000 gallons of the stuff. Enough to fill 6 swimming pools. Like the blood in your body, mud is pumped through an elaborate circulatory system in the oil rig. 3 giant pumps in the rig's hull first push the mud up to the drill floor, then down through the drill pipe. When it reaches the bottom of the well, it spurts out through openings in the drill bit, floods the hole and starts back up again, carrying with it bits of drilled rock called cuttings. When the mud and cuttings get to the top of the well, they are transported to 3 machines that separate the cuttings from the mud. This high-tech mud is so expensive, almost every drop is reused. Current laws allow these cuttings to be dumped back into the sea. If they were using toxic oil-based mud, every bit of chipped rock would have to be shipped back to shore to avoid contamination of the environment. Energy companies used to dump these toxic rocks back into the sea, but now they're acting more responsibly. In fact, today, around the world, only 5% of petroleum in the sea comes from oil exploration and extraction. The key to controlling pollution is having all parts of the mud system work together flawlessly. It's also the key to safety. If there's not enough mud in the well when the drill actually hits natural gas, the explosive gas can rush up and ignite. It's every rig worker's nightmare, a blowout.
Right, so there she goes. Explosion and fire on the Piper platform.
In the summer of 1988, explosions ripped apart North Sea rig Piper Alpha and woke up the world to the dangers of offshore drilling. A gas leak set off the first explosion, which was so destructive there was no time for an orderly evacuation.
Platform is completely on fire from sea level to top.
167 workers out of 225 were killed, mostly from toxic fumes. The Piper Alpha was the worst, but by no means the last disaster aboard an oil rig. The official investigation found numerous violations of safety rules and led to many reforms. So today on an oil rig like the Noble Piet, workers participate in a seemingly endless series of safety drills.
Attention all personnel, this is the drill.
Today's simulation is that some scaffolding has collapsed. They've found one roughneck. He's been crushed and is near death.
Emergency control.
More people may have been injured, so they need to account for everyone on board. In the mess hall, driller Noel Shembri and assistant driller Paul Brehavis are responsible for making sure everyone is present.
Yes, this is lifeboat number 2 speaking. We have 15 people present, including myself.
It's 7 p.m., so the count tallies both day and night crews. The Noble Piet is ready for an emergency.
This is a drill.
With high-tech lifeboats that can brave fiery water, a speedboat to save men who fall overboard, and a rescue boat that circles the rig 24 hours a day, ready for a catastrophe. This is just a drill, but they make it feel real. That way, if there's a real accident, they'll save precious minutes and maybe lives.
We have ordered a helicopter to come and pick you up, okay?
If they were really requesting a helicopter, it would take 45 minutes to get here, and another 45 minutes to reach the nearest hospital in the Netherlands. That's not a comforting thought, but it's the reality of life on the rig. Safety is always the #1 concern, and not just in the North Sea. Back at the Singapore shipyard, they're battling the elements to move a new rig without a disaster. In the North Sea, 96 miles off the coast of the Netherlands, the mega oil rig Noble Piet is racing to drill for gas miles below the frigid waters. It's dangerous work. Meanwhile, in Southeast Asia, on the island nation of Singapore, workers at the vast Keppel Fells shipyard are building the newest generation of mega rigs under super tight deadlines. It too is dangerous work because a shipyard is an accident waiting to happen. So if workers forget to wear their safety glasses or their safety belt, they'll get a sharp reminder.
Hey, one man stand behind, watch out.
But at the shipyard, safety means more than protecting the workers. It also means protecting the rigs themselves. The oil rig that's just been assembled in the dry dock is ready to be towed out. It needs to be moved to a wharf a few hundred yards away, where workers will spend 6 months finishing it. But there's a problem. This rig is one of 3 mega rigs waiting to leave the dry dock. 2 other rigs are blocking it. One's a jackup, and the other's a type of rig called a semi-submersible. In theory, it should be a simple maneuver. Just flood the dry dock and float the rigs, then open the gate and tow them out one by one. In reality, the maneuver is anything but simple. The process is incredibly complex, and they've scheduled just 2 days to move all 3 rigs. Not only that, the whole operation is extremely dangerous. The rigs are huge, and there's very little space between them. If they collide during the move or hit the walls of the dry dock, it will be a disaster.
We have to be very careful because any damage to the vessel or to the dock will cost us millions of dollars.
The process of removing the rigs from the dry dock is called undocking. They're under a strict deadline to undock these rigs right now because dry dock space is the most valuable real estate in the shipyard. To keep the rest of the operation on schedule, they need to clear this dry dock for the next round of rigs. But if they're not careful, undocking could pose a threat to the environment. Work on the hulls has littered the dry dock with grit made of copper and steel. It's a real mess. If they don't scoop it all up, this metallic debris could end up polluting the Singapore Strait. By late morning, the workers finish the cleanup. They put up a red flag to show they're ready and open a valve to let the water in. It's more of a trickle than a gusher. At this rate, it will take all night to fill the dry dock. And the clock is ticking. By the next morning, the water level inside the dry dock has reached only 21 feet, not high enough. This unexpected delay is going to be costly, with workers waiting around on the clock. Lim Yu Seng, known as Captain Lim, is in charge of the undocking. It's his responsibility to meet the deadline. He knows undockings are always risky.
It's not as easy as anybody could do it, you see. You need very special skill in order to maneuver it out without even her touching anything at all. Okay. We want her to move out very smoothly and gently.
Smoothly and gently will be tough to pull off today. Lim's worried. The forecast is for wind and rain. If the storm hits, he'll have to call off the undocking, and that could shatter his tight schedule. 3 tugboats are standing by because the rigs have no engines to propel themselves out of the dry dock. Captain Lim gives the order to open the gate.
Okay, John, you're opening the gate now, John.
Slowly, almost imperceptibly, the gate begins to lower. Finally, the tugs start towing, and the huge semi-submersible rig begins creeping toward open water. But Captain Lim's luck doesn't hold. The weather is against him. He makes a tough call: close the gate.
In order to prevent the semi and the 2 rigs in front from any sudden movements, we have no choice but to close back the dock gate again. And we will only resume our operations when the weather is back to normal.
It takes 2 hours for the squall to die down. When it does, Captain Lim seizes the moment. He orders the tugs to haul the first rig out into the harbor. This rig is so massive, even these powerful tugs need time to build up speed. Finally, the rig clears the gate. That's 1 down, but there are still 2 more to go. And now it's late in the day. They haul the second rig closer to the gate before the weather can change. Once again, Captain Lim gives the go-ahead. The rigs start moving. With luck, the wind will stay calm long enough. And it does. The second rig clears the gate and makes it out into open water. But it's too late in the day to move the third rig. They'll have to wait until morning. The next day, the sea is rough and a strong wind is blowing. Captain Lim tries to put a positive spin on the situation.
Everything is going very smoothly except for the weather is a bit rough this morning.
He knows that he's behind schedule. He can't delay any longer. In spite of the wind, he gives the go-ahead for the gate to be opened. Then he signals the tugboats to start pulling to move the rig out.
Okay, I'll let go.
Time-lapse photography shows the rig weaving back and forth in the wind like a drunken sailor.
Hey, let go.
As the rig pulls past the gate, it just misses a $1 million scrape. Then the tugs haul the rig toward its new home at the wharf, where Captain Lim hurries to guide it in. It's a tight squeeze.
Captain Tanner, go in more, another 1 meter, be okay?
The rig finally docks. Now it will need to stand on its own 3 legs while it's being completed. But the Jackup system has never been tested. If it fails, it will be a major setback. The 36 jacking motors are started. For the first time ever, this Jackup rises out of the water. The rig passes the test, but it's still not home free. It will take another 6 months of grueling work to finish construction. After more than 2 hair-raising days, Captain Lim can breathe easy. He has moved all 3 rigs. The dry dock is ready for his next job. In spite of some close calls, he's kept his rig safe and the production line moving. In the North Sea, however, the Noble Piet's mission is about to grind to a screeching halt. Back in the North Sea, the drilling crew of the mega oil rig the Noble Piet has reached a depth of more than 10,000 feet below the sea floor. But now something's wrong. They've only drilled 80 feet in the last 12 hours. That's 500 feet less than they'd expected. They must have hit some kind of snag. But the instruments aren't showing any problems. The pressure in the well is stable, and the drill bit's rotation is constant. So they look around for an explanation. First, they check the bits of drilled rock coming up from the well. The fragments will reveal what type of rock layer the drill is grinding through right now. Hard rock like granite or marble would explain the slow progress. But under close inspection, Tom Brangies only sees salt. The drill should be grinding through the salt 8 times faster than it's going. Clearly, the problem is not in the material they're drilling through. This could be bad news. Drilling Chief Tony Wilpshire wonders if the problem could be an undrillable well.
But sometimes you have these wells, they don't want to be drilled. Sometimes the problems are so big, they can't be solved, and then it's not economically worth to do it, you know, the profit afterwards will be nothing.
If this well proves undrillable, they will have wasted 40 days and over $2 million. Tony knows that the only way to find the problem is to haul out and check all 10,000 feet of drill pipe. This is the worst part of a roughneck's job. The pipe must be pulled up and each 90-foot section detached and stored in a corner of the drill floor. It's grueling, messy work. Drilling mud is everywhere. One at a time, they must lift over 300 heavy pipe segments out of the sea. This job is too big for the roughnecks to handle by themselves. That's why Carl Gregg is perched 147 feet up in the derrick.
Okay.
He's using a robotic arm to grasp the top of each pipe and place it safely in a rack. But coordinating the move of a 90-foot pipe is risky, especially when the men grappling with the bottom end look like ants. Carl can't even see them directly. He's totally dependent on a video monitor and hand signals. Even with this communication, it's a dangerous lift. If Carl opens this claw too early, the pipe could fall on an unsuspecting worker. It takes 8 hours to remove all the pipes from the hole. A massive effort that will be a total waste if Tony's inspection fails to reveal the problem. But when the last pipe finally emerges, it's immediately clear what's been slowing their progress. A mangled drill bit. Inspection reveals that several of the diamond tip points broke off during drilling. Spinning loose inside the well, these ultra-hard diamond tips ground into the drill bit, wreaking extensive damage.
A lot of cutters lost, you know. Here, 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 there. All these cutters being lost.
The roughnecks grab another drill bit, one they hope will hold up, and attach it to the first pipe. Now they send the new bit back down into the hole, reconnecting all 300 pipes, one by one. It will take another 8 hours before the drill reaches the bottom. The drill should now resume digging unimpeded. But they've lost precious time. It's been an exhausting day for assistant driller Paul Brehevis. When things don't go well on the drill floor, roughnecks work twice as hard. And Paul has spent 8 of the last 12 hours hauling out drill pipe. Now, at last, his shift is over. If you work 12 hours and sleep 8, there's not much time left for anything else. And if you're sweaty and grimy, life's on hold till you get cleaned up. When you're as tired as Paul, an oil rig can seem like the world's biggest stairmaster.
Here's my apartment.
Like almost everyone on board, Paul shares a cramped cabin. But cabin mates rarely see each other. Paul works the day shift. His cabin mate works nights.
Okay, thank you.
At mealtime, people often don't have the energy to talk. But at least the food's not bad. After dinner, the roughnecks try to unwind. But it's tough to forget about the job. It's claustrophobic inside, and everywhere you go there's a reminder that you're still at work. Even out on deck, a homesick roughneck can only stare at the ocean and count the hours until R&R. So workers relax as best they can. Hitting the gym. Hanging out with friends. Or watching whatever movie's on board, even if it's meant for kids. Over time, the workers grow close like family, but there's only so much togetherness they can take.
After 2 weeks, we are very glad we don't see each other for 2 weeks anymore.
But there's a payoff. These 2 weeks of grueling work earn them 2 weeks of uninterrupted home time.
I see my children go to school and that sort of things, and that's important for me. Not just weekends, huh? It's I'm 2 weeks off, but then after that I'm 2 weeks full-time daddy. And that's very nice.
For the workers, it's a constant trade-off between great rewards and great risk. After all, 3 metal legs are the only thing protecting them from the frigid waters of the North Sea. Back in Singapore, this newly built leg section is ready for its oil rig. It towers 112 feet high and weighs 230 tons. How do they move a structure this tall and this heavy to the rig? They can't. None of the shipyard cranes can handle the job. So they call in Hercules. Asian Hercules 2, that is. A 400-foot tall floating crane. One of the largest in the world. It's so powerful it can lift more than a dozen leg sections at once. But attaching the leg section to the crane is a huge job in itself. So they call in the Spider-Men. Workers use harnesses or scaffolding for protection when they're high above the ground. But these men are specially trained and climb the 98-foot ladder without a safety net. Once they reach the platform high above the shipyard, the Spider-Men wrangle thick cables hanging from the crane and shackle them to each corner of the leg. Then it's back down to solid ground. And we have liftoff. Dangling from the monster crane, the 112-foot leg section looks like a child's toy. As the crane approaches, a crew on board the oil rig rushes to prepare for the new leg section. Finally, contact, and the workers align the new leg section with the old. Now the two must be attached permanently with indestructible welds. In the coming weeks, they'll keep adding sections until the legs tower 430 feet into the air. That's almost as tall as the Great Pyramid in Egypt. But it will take a lot more than just adding leg sections to finish this rig. And the deadline is looming. And out in the North Sea, the Noble Piet's drillers are again in deep trouble, almost 3 miles deep. Dead in the water, the probe signal flatlines, jeopardizing the rig's multi-million-dollar mission. At the shipyard in Singapore, there's only 5 months left to complete this new mega oil rig. The main deck of the new rig is a tangle of steel and scaffolding. And below, crucial equipment and supplies still have to be installed. There's an overwhelming amount of work to do, and there's a rookie in charge. This is Brian Lowe's first stint as project superintendent.
Careful, start with the outside first.
The superintendent has to oversee all the workers
You have 1 man to watch out for any break.
and make sure they get the rig completed in time. While in the dry dock, a workforce of more than 800 people was dedicated to this one rig. But the superintendent has been given only 300 workers to complete the job, and he's anxious.
We got to push our people. Our operation is 24 hours, you see. So sometimes our men are working late. We have night shift coming in. So to be honest, I'm a bit worried as well, even during my sleep.
Managing a job this massive is nerve-wracking under the best conditions. Brian has to be everywhere at once.
So later I'll call Wilson Fong. You teach our people how to open up the air temper, then you can run the engine. Super the area.
And he's not sure his workers have enough time between now and the deadline to do everything. Like transform this raw steel box into living quarters for 122 people. And finish the mess hall, which must feed more than 50 hungry rig workers at a time. With a kitchen worthy of a fine restaurant. And then there's the drill floor. It's still just a skeleton, with the drilling machinery dangling in an empty derrick. And as long as there's oil down there, the frantic pace will not let up. Back in the North Sea, on the Noble Piet oil rig, the drilling continues. The drill bit is now turning 12,000 feet beneath the rig, and the work has reached another critical point. The bit is nearing two pockets of high-pressure salt water. If they pierce one, salt water will shoot up the hole, possibly destroying the well and exploding up at the rig. Noel Schembri has to carefully guide his drill between these two danger zones. By adding or removing weight from the drill pipe, he can steer the drill bit at the bottom of the hole and change its course. But when the drill is more than 2 miles away, he's essentially navigating in the dark. Transmitting its location and direction, a probe near the bit provides his only guidance. But suddenly, Noel loses the probe signal. It flatlines.
Yeah, we're getting nothing down here at the moment, so...
Now Noel's team has no way to know how close the drill is to the dangerous high-pressure pockets. So they immediately stop drilling. They run tests, hoping that it's just a computer glitch. But there's still no signal.
You can see the pressure, when the pressure going down. Yeah.
So the trouble isn't the software, it's the probe at the bottom of the hole 12,000 feet away.
Yeah, it's the tool that's not reacting.
Incredibly, they have to haul the pipe back up out of the well, all 400 lengths, for the second time in 3 days. 8 long hours later, the last pipe which holds the probe surfaces. But the $700,000 probe is stuck inside. It's a high-tech device, so they try to be gentle. But the probe won't budge, so they have to get tough with it.
Good retention on it. What?
Finally, it's out, but there's no time to fix it. Fortunately, there's a spare. 12 hours later, the drill, with a new probe, is back up and running at the bottom of the hole. The new probe is working. Its signal reveals that the drill is excavating right between the danger zones, threading the needle perfectly.
As long as we keep away from these two floating blocks, number 1 and number 2, we should actually carry on just do the perfect job there.
Yeah.
But they still have 1,000 feet to go before they reach their target. Now it's just a matter of time. Several days later, the Noble Piet strikes a reservoir of natural gas. It will take up to 2 weeks to retract the drill pipe and replace it with a concrete lining. Then, the well will be connected to a pipeline leading to shore. The Noble Piet will successfully complete its mission. The team will jack the rig down off the permanent platform, and tugs will tow it to its next assignment, somewhere else in the harsh North Sea. Back in Singapore, after more than 2 years of constant deadline pressure, the new oil rig is finally finished, on time and on budget. Its legs tower hundreds of feet above the water. Tugs are towing it out to sea to begin the voyage to its first assignment, off the western coast of Australia. When it gets there, it will jack up and go to work at a rate of up to $105,000 per day. But the Singapore shipyard can't afford to rest, even for a moment, because the world's demand for oil and gas won't rest, forcing shipyards to build tougher and more efficient mega oil rigs to drill deeper and deeper beneath the sea.